for some reasons, this station has only 1 second processing time, and it has to wait until all 3 stations are ready to move the part to the station. So I want to collect these 3 parts, and if 3 parts are processed completely, then the 3 parts should be moved to the conveyor. The basic behavior here is another one. Now it starts with 2 parts, and the 3rd part, now another 2 parts, wrong parts. Now it comes the white part here from the 3rd machine. So this behavior is wrong. It should move 1 pair of 1 combination from part E, part B, and then part C. One way could be to create pull control. The pull control should wait until 3 parts are waiting in front of the machine, and then you can release these parts one after the other. To create this, we need some additional. We need 1 variable, for instance. I call it start, a Boolean variable, and initial value should be false. And we need a counter here to count for 3 as a global variable quantity, and initial value is 0. Okay. And then you find the pull control in the tab controls. Here, the pull control will be called if the station can receive 1 MU, and if at least 1 predecessor is finished and wants to move this part on the station. And then the pull control is called. If you create a new method, then you get already one. It's for the first step. What happens here? If you have some predecessors finished for moving the part on this station, then Blend Simulation enters these parts here into the forward blocking list. You can have a look in this list here in the station view, and then you have a forward blocking list here, or F9, and you can see, okay, the time, the simulation time, and the parts that are blocked by this station here. All stations are in this state blocked, and here this is part E1, part B1, and part 1. These are the parts are blocked, and you can see this in the forward blocking list. And the SymTalk code to access this list is FW block list. And now I want to wait until 3 parts are entered into this block list, and so I need to define some cases here. And one case is if block list. It's a table, or it's not a table, it's an array. And so I need to check with dim the number of parts inside the array. And if the dimension, if dim is 3, then I want to start the movement of the parts. And I need to set my quantity to 1. And I can, for each call of this pull control, I can only unblock one part. And then the pull control is called anew. And so I cannot unblock all 3 parts in one step. And so I need to remember that I start unloading this, moving these parts, and I need to count the parts because I only want to move 3 parts. And with unblock, you can unblock one of the MUs from this array from the block list. And so it's block list 1. It's the first one. And this will release 1, the first in the block list here, 1 MU. I can check this. Okay. And make a breakpoint here. So this was working, and now block list has 3 elements in it. And I unblock part E. It's the first one. I can also unblock the second or the third one. And after this, the first MU is unblocked, and now start is true, quantity is 1, and now I can directly move the second part in the second call of this on pull control. And so I need this is my variable start. If this is true, then I unblock. It's the same method, same command here. I unblock the first in this block list. Increase my quantity. And if quantity is 3, then I stop the movement of the parts. By setting start to false. Then after the next call, it checks if the block list is complete full. If the block list is again 3 with 3 entries, and then I set start again true and quantity to 1, and then starts again. And so you can use this pull control, the basic default pull control, if you want to change the order of, if you want to control the order of parts that is coming to the station, or if you need to wait for completing, for instance, a batch and run the batch through the production. And like in this case, so now comes the parts in the right order from this station. And again, you can use the pull control if the basic push behavior leads to a wrong behavior. This pull control doesn't work for if one of the predecessors is a store. The store doesn't have active exit behavior. It doesn't try it. The store doesn't try to move the part actively to the successor. And if you have stores, then you need another approach to pull parts from the store. So a second really easy to use way to create a pull control is the exit control rear. I want to make a small use case. I have a box, a filled box. So I take container created by a source, and then I need a buffer. And this source only creates 4 boxes. And then I need a assembly station. And a source for parts. To fill this this box with parts, it's now easy in the newest version. You can select here fill up main MU. You don't need to specify how many MUs, how many parts you need. And I want to attach the MUs to fill my container. And then I have a station. You can find a lot of processes where you need to assembly parts on carrier, for instance, if you have painting processes or heat treatments, or there's many cases, or washing processes, you need to fill the parts in the baskets. And then maybe you have a process where you need to process out of the box on a machine. And if you connect these 2 machines with a connector, then your container will move to the next machine. And this is, again, not the right behavior. Okay, let's check this. Okay, I fill this container, then the box is here, the container goes to the station, and yes, the basic behavior is along this connector. This container will be moved to the next station, and there is the processing. But I want to change this basic behavior. I only want to move the parts to this station. And this you can do with the exit control rear. You need to move the first part here in the exit control from this station to the next station. And then you can use the exit control rear to pull the parts out of the box to this machine. And so it's it's only some lines of code. So here we need exit control. And this exit control just moves one part out of the box at .cont .move, and it was station 5, I guess. Yes. This exit control will be called only once. Another way could be here to make a loop until this at is occupied, move parts to station 5. This would be a push again. You need to wait until station 5 can receive parts, is finished, empty, operational, and so on. Another way could be to create a pull control. So I make one method. And this pull control is the exit control area of this station 5. So it's called when the part has left station 5. Station 5 is empty, and I can pull the next part on the station. And this is station 4.cont. This is my container.cont is one of the parts on the container. And this I move to station 1, to station 5, or I can use the question mark. This will be replaced by the station with the control here. And then if station 4 point empty, and then I can move the empty box back to the start of this line here. And so you can use the exit control area in a very simple way to create pull controls at the right point in time. The station is empty, and let's check this. So the first part is moved by the exit control, and now it's already running the pull control, pull all the parts out of the box, and then move the box into this buffer. So this is quite easy. More complex could be tasks if you need to check in a store, for instance, if you have all parts you need to start the next step. And so in the next way, and the next step, I want to show you one pull control using a recursive method, method that is calling itself. Okay, I want to have one basic scenario. I have a source, and this source creates parts randomly. So I need a data table here, and I set the mu selection in this source to random, assign this data table, and then Plan Simulation will format this data table. I want to create part E and part B. 33 and 67% each one. And to make it more random, I want to have here random interval, uniform distributed between 10 seconds and 50 seconds. So I have a random behavior, and I have a station. I have a station, and I have a store, maybe 10 by 10. I connect this with connectors. And now the task is I need to collect 4 part E or 4 part B, and move this 4 part B or 4 part E to a buffer. So I need to wait until there are at least 4 of these parts in the store. And this could be, okay, you need to collect all parts you need for sampling process, and then you have a pre-processing, and this should be only start if all parts are available. Yes, and this is quite complicated because also if you write inventory here, you cannot wait for one cell inside a table. And so you cannot use wait until to create a condition when this movement starts from the source. And one way to do this, you can make endless loop for waiting for the right condition, or you can use a recursive method to do this. Okay, some more elements. I need a buffer here. It's now my buffer 1. And I want to load these parts onto a container or into a box here. Right. So I need an assembly station. And to see what's inside, I place a station here and a drain. And I need a source for the box. And the box should have 4 dimension here, not 3. And then I connect the box with the assembly, my buffer with the assembly station, and then the assembly station with the station, and the station with the drain. So here again, fill up main mu and attach mu as configuration. And then I need one method to collect 4 parts. Okay, I need a method here. And I need an init method for the first call of this method. This is the first call, and all the other calls the method does by itself. So inside of this method, at the end, we need a command self execute in, and you need to set a delay so that the simulation can run further and create a new state. So, and inside of this method, you can do calculations, and you can run through the complete store to search all the parts you need, and you can work with data tables. You don't have any limitations inside such methods. For instance, I want to have two variables here, num part E, num part B integer, two variables for the number of these parts inside the buffer. I want to use the contents table of contents list of the store. So I need a table, and I read the contents table of the store into this variable. So I have the contents list of the store, and yeah, it depends on your store. If you don't have a set variable, the contents list is a two-dimensional table. If you have more than one set dimension, then you have a table with lists in each cell, and this makes it more complicated if you want to run through the complete store to find your parts. And so to find parts here, I need two loops. So two loops for my table, and then I check each cell in this contents list. Okay, it's got one. This is void. If there's no parts on this place, then it returns void, and this we need to check. Okay, and this would. So easier way would be to write an inventory, and then you can check the inventory for part E or part B. And if this inventory is greater or equal to 4, then you need to move the right parts, and you can do this using the method find part. And find part is also a method for pulling parts out of the store. You hand over the name of the part. It returns void if there is no such a part in the store. But we have already count the number of parts, and so we can copy this 4 times to move 4 parts to buffer 1. And the same is for part B. Then I can use part B again and again to move 4 times part B. Okay. This could be much more complicated if you have a list of parts that all need to be present in the store. You can use find part and check if all parts find part commands returns not void, and then you have all the parts you need, and then you can move the parts. Otherwise, you need to wait another 5 seconds. And so it can be incredibly complex to check all this stuff. And this you can do with this constellation, with a method that calls itself with a delay that the simulation can run another 5 seconds to check again the condition. Yeah, lower the time here, let it run a little bit faster. So now it's only 3. Now we need to wait for the 4th, and then we can collect them and move them forward. And so you can collect batches, you can collect all different kind of stuff inside a store, and then check, okay, it's all present in the store, and then you can move them forward, pull them out of the store. The easiest way to create pull controls in plant simulation is to use the assembly station. The assembly station is able to pull parts that it needs out of the store. And so we can create complete pull controlled production systems using the store. And the starting point for such systems is the consumption of parts, the selling, for instance. And so as the third way to create pull controls is store with the function supermarket. And normally you have, again, the source, and the source creates here orders. So I take the container again, and the orders will be collected by the assembly station. Now I want to have MU types. I want to have part E, Q, and part B also to. And I want to attach MUs. And here it's really important to set an interval. For instance, every 5 minutes, you have to deliver this customer source train here. And then I take the store and connect this with the assembly station. And here the store, I don't know which version, I guess 16 something. Before, Blend Simulation had some Kanban elements, a library for Kanban. And I guess 16.1, I don't know exactly, all these functionalities Siemens included into the supermarket, into the store and the source. And now this supermarket can function in a special way. You can define part types. Part types means here the part classes. Okay, it's part E. Name is part E. Minimum stock is maybe 10. Maximum stock is 20. And we need we can start with 15, for instance, and we need to define a supplier. And here I want to have a source. It's source 8 in my case. And this source can have here a special MU selection order controlled. So this source will create parts whenever it needs to deliver parts, and it's can deliver parts, can deliver different parts. And here, this is my supplier, source 8. And if the stock is below 10, then it orders 10 until the maximum here from the source, and this source will produce these parts and pushes into the production. And then I need a second one. This is part B. Maybe minimum 5, maximum 10, and we have 7, and the same source should deliver this. And now it works like a Kanban. If the stock falls below this 5 or 10, then the right number of parts and the right sort of parts will be requested from the source. And then usually you have several production steps you have to go through. And at the end, these parts come back to this store. And you need not one line of programming to create every 5 minutes. Yeah, I changed this interval to 1 minute to make it better observable. So now you can see it's consumed the parts pulls the right parts from the source. It runs through the production and fill up the store again, and then again, it will the assembly station consume parts. This works automatically. You don't need to program anything, but you can also set here as a supplier a method, and then it calls the method, and then you can do whatever you want to fill up the store again. And normally this have several stages. You not have only a final store. You have interim stores where the supplier here is the interim store, and the interim store orders the parts from a source. And so you can create Kanban systems with several stages, and you don't need to program to do this. Okay. A little bit longer than 30 minutes. Are there questions? Okay, let's have a look. Wait.
So yeah, I think Vladimir put a question in the chat. Are you able to see it?
Okay. What do you think? Does it make sense to use move in pull control? For example, parts come in boxes. Station should process parts individually. Pull control can be used to choose from the box to process parts and then move all parts from box to station one by one. I see a problem that pull control will be called not only for boxes, but for moved part as well. Okay, the original pull control is called by the MUs from the predecessor. If a box comes from the predecessors, then the pull control is called by the box, not from the parts inside the box. And to move the parts out of the box, you cannot use the pull control. The pull control is only called once, like the exit control, and then if the it will be called again if you move instead of the box a part out of the box, and then the station becomes empty, and then the pull control is called anew. So you can also use the pull control to unload the box, yes. But move, you need move if you want to move parts. You don't want to unblock the box, but I guess it doesn't work. You cannot move. I think you cannot use the pull control to unload the box. Once again, I don't think move is working inside the pull control. You need to unblock. Otherwise, it doesn't move anything.
Okay, so what you should see on your screen right now is an image of our forums for the Plant Simulation Virtual User Group. You can also click on the links that are there, and that will take you directly to the page that you see. The illustration is showing you that we recommend that you follow the topic by clicking the button, then clicking the small envelope icon to get every post. The only thing that we post there are recordings and registration links for this series. And also, if you have questions about the series, you can put them there. So we do recommend that. And then you'll see the next meetings, which you can also click those links and register now. So Stefan will be back with us 2 weeks from now, but on Tuesday. So I know this time was a little bit different. This next one is on Tuesday, not Wednesday. But it should also show for 1 p.m. And then the last session of the year will be on actually, gosh, December 10th is Wednesday. So that is another typo. When you click through, you'll see that it says that that is on Wednesday. So it is December 10th for the last session of the year. So both of those you can register for now, but if you go to the forums, we'll also have the registration links there. And then last announcement, or last couple of announcements, Siemens, we have the Siemens Accelerator Academy. So if you need more comprehensive training on any of the topics you see on your screen, click through the links there. You'll be able to get to those and register for how you get to those, including the Plant Simulation Associate Certificate, if you're quite new. And then for everyone who was here early, you already saw this link. If you are interested to answer the survey, we definitely appreciate it. It takes about 5 to 7 minutes, and our customer experience team is trying to gather information on how you use the license management. So that's all I have for announcements. There's still some time for questions. We do have a few minutes left. Survey link is there. Stefan's link to his forum profile is there, and the link to the forums is also there. Recording will be available on Friday.
Oh, searching with Lutz. Yeah, to write a better way would be writing inventory, and much better is to use a database behind your store, and then you can search your stuff with SQL. And this is much faster if you have big stores. And so having an inventory, it's much better than search through the store. Yes, it will slow down your simulation.
I hope that answered your question, Amir. Okay, we got a thumbs up. Yeah, thank you. And thanks for all the applause.
Thank you.
Yeah.
Okay, until next time.
Bye.
Bye.